Imaging live animals is very different from imaging cells or tissues. Here, we will review key considerations and best practices for your live animal imaging studies. Topics will include animal prep, anesthesia, and motion correction. If performing optical or ultrasound imaging, we suggest you remove the fur. For optical imaging, fur blocks light. This will happen whether your optical source is bioluminescent or fluorescent. For ultrasound imaging, the fur will interfere with the acoustic signal. We recommend using clippers to remove most of the fur, and following up with the depilation cream like Nair to remove all remaining fur. Be sure to remove all extra cream to avoid chemical burns. This procedure should be included in your animal protocol. We keep live animals anesthetized so they are immobile for the duration of the imaging experiment. Options for anesthesia are injectable or inhalable. We prefer to use an inhaled anesthesia like isoflurane, which has a low boiling point and is carried by a gas into the imaging chamber using tubes. We typically anesthetize animals using an isoflurane induction chamber that can be purchased as an optional accessory with your IVUS. The anesthesia assembly delivers a mixture of oxygen and isoflurane to the induction chamber, which is inhaled by the animals. The gas mixture is also channeled into the IVUS to a manifold that splits the gas line into multiple ports so multiple animals can be anesthetized at once. There is also an active scavenging exhaust system, consisting of a pump that routes excess isoflurane through a carbon filter. The filters need to be weighed often, and the charcoal replaced according to the manufacturer's instructions. Once you turn on the vacuum and oxygen source, choose your flow rate and select the percentage of isoflurane to use. Usually starting at 1% and increasing as needed is a good rule of thumb, but please consult your veterinary staff and animal protocols for allowable doses. Breathing is a good visual cue to determine the accurate percentage of isoflurane to use. If the animals display labored breathing, drop the percentage. Once the animals have reached the desired depth of anesthesia, transfer them to the IVUS. If you smell isoflurane when you open the door, you may need to reduce the oxygen flow rate and/or increase the exhaust flow rate. Again, check the animals to ensure they're neither waking up nor displaying labored breathing. Please note that different animal strains can respond differently to anesthesia. Also, sick animals may be more sensitive to anesthesia than the healthy controls. If you have any questions regarding the proper anesthesia type, delivery, or dose to use for your model, please consult your veterinary staff. Lastly, there may be some motion that cannot be corrected for with anesthesia, namely the diaphragm with breath and the heart with cardiac contractions. For optical imaging, this type of motion is not typically a problem. However, for anatomical imaging modalities like CT and ultrasound, heart and lung motion can impair results. Anatomical motion is typically corrected for by using gated scans. Gating is an image acquisition technique that separates images into groups, for example, inspiration and expiration for lung, or systole and diastole for heart. The instrument can be triggered to only scan during a specific portion of the respiratory or cardiac cycle. Alternatively, the instrument can scan for a period of time and then sort the image projections retrospectively. Thanks for watching. If you have questions about experiment design, image acquisition, or image analysis, please contact your team of Revity application scientists.